This is question number 1 on section 6.4, and for these problems you can solve by any method, substitution or elimination. And whenever you have a variable that's been isolated when you have a linear system here, I would use the substitution method. So let's go ahead and copy out the first equation, highlighted in green. So if I recopy that, the 3x plus 2y equals to negative 15. And if I take a look at my second equation, I notice that x equals to all of that. So whenever I see x in the first equation, which I'm highlighting green, that's going to be replaced with the second equation there. So instead of writing this x here, all of this x is going to be replaced by that, which is going to be 2y minus 1. And then I can copy out the rest here, which is plus 2y equals to negative 15. Okay, and then from there, we can just use our algebra skills here, distribution and collect like terms. So if I distribute this, 3 times 2y is going to be 6y, and 3 times negative 1 is going to be negative 3. And then the rest of the problem will just follow down, and then we can collect like terms from here. So if I have 6y plus 2y, these are like terms. So 6y plus 2y, that's going to be 8y. And then the minus 3 remains, and then I have a negative 15 on the right hand side. After that, I would take my negative 3 and move it to the right hand side. And since that negative 3, it's negative, if I bring it to the right hand side, the sign changes and you get positive 3. Alright, so now I have 8y equals to negative 12. And then from here on, I can divide both sides of the equation by 8. And you'll notice that these 8's cancel off. And then I have y equals to negative 12 over 8. Now, negative 12 over 8, if I reduce the fraction here, that's going to be negative 3 over 2. So my y value is negative 3 over 2. Now, what we have to do now is we need to go back and solve for x now. And if I go back to the original question here, if I go ahead and highlight the second equation here, we know that x equals to 2y minus 1. Let's just recopy that. And I know that the y value here, that has a value of negative 3 over 2, right? So we just solve for the y, which is negative 3 over 2, and then the minus 1 remains. All right, so now we just kind of compute this. This 2 and that 2 cancel off, so the negative 3 remains. And then I have a minus 1 here. So x would equal to negative 3 minus 1, which is negative 4. And that's how you solve the very first question on section 6.4. Okay, let's move on to the question 1c here, solved by using any method here. Now, what I see right here is the y variables are isolated. What that means is y is by itself, so I would use the substitution method again. So I'm going to rewrite the first equation here. This first equation, which I'm highlighting in yellow, I'm going to replace that. So I'm going to rewrite that as y equals to negative 3x plus 3. All right, so that's the first equation. Now take a look at this y right here in blue. That y is equal to this y right here. So what that means is this y on the left hand side in the purple box, I can replace all of that with negative 2x plus 1. So if I do that, I get negative 2x plus 1. And then on the right hand side, I get negative 3x plus 3. Okay, and then from here on, you want to rearrange the terms. You want to get the variables on one side and the numbers on the other side. So if I take a look at this negative 3x, I want to move that, and I also want to move this plus 1. So you have to be able to do that in your head fairly quickly here. So if I move the negative 3x over, that becomes positive 3x. And then if I move that green 1 to the left-hand side, that becomes negative 1. And then the plus 3 remains. And then from here on, we just collect like terms. So on the left-hand side, negative 2x plus 3x. Negative 2 plus 3 is 1, so I can leave that as x. 1x is the same thing as just x. And then if I have a negative 1 plus the 3, that's going to be 2. So x has a value of 2. Great. And then after that, we want to go back and solve for y. Let me just erase this. Now, it doesn't matter which equation you use. You can use the first guy or the second guy. I'll just go ahead and use the second equation here. So if I rewrite the second equation, I have y equals negative 2. Now remember, we did solve for the value of x, right? X has a value of 2 here, and then I have to add the 1. So y equals to negative 2 times 2. So negative 2 times 2 is going to be negative 4, and negative 4 plus the 1 is going to be negative 3. So y would equal to negative 3. All right, so our answer is 2 comma negative 3. Okay, let's move on. Okay, let's move on to question 1G. This is the last kind of review question, and then we're going to move on to the word problems. I picked this particular question because I liked that this problem has fractions, and when you have fractions, you want to get rid of the fractions by timesing by the least common multiple. Now, let's take a look at the first equation here. There's an 8, there's a 5, and there's a 2, right? So those are the numbers on the denominator, and what we want to do is, what is the least common multiple between 8, 5, and 2? So if I look at 8, 5, and 2, I can tell that the least common multiple is going to be 40. All right, so 40 is going to be the least common multiple. And what that means is I'm going to times everything here by 40. Actually, let me just put the 40, yeah, I'll put the 40 over here. I'm going to times by 40. Usually in class, I would put the 40 on the far left-hand side, but I just don't have enough space here. Now, when you're multiplying by 40 and whenever you have fractions, I would always do division first. All right, so let's take a look at this. What is 40 divided by 8? Well, 40 divided by 8 is 5. And 5 times the numerator of 1 here is going to be 5, right? So once again, it's 40 divided by 8, which is 5. And then 5 times the numerator, which is 1. 5 times 1 is 5. So I get a 5x. Okay. All right, after that, let's do the second term, which is 40 divided by 5. What is 40 divided by 5? Well, 40 divided by 5 is going to be 8. And then what is 8 times 3? 8 times 3 is 24. So I have a plus 24y. All right, moving on. What is 40 divided by 2? Well, 40 divided by 2 is 20. And then 20 times 19, if you have a calculator, that's going to be 380. All right, so this one here, I don't mind if you want to use a calculator to do some quick calculations like that. I'll try to keep the numbers reasonable on a test there. And if you times by the least common multiple, which was 40, notice that my expression here in blue, there's no more fractions. There's no more denominators, right? So the fractions are all gone here now. Okay, let's do the same thing for the second equation. Now, if the second equation is a little bit easier to find the least common multiple, I have a 10 and a 20. Those are the numbers on the denominator. Now, 10 and a 20, the least common multiple between 10 and 20 is going to be 20. It's usually the bigger number. So I'm going to multiply everything on the second equation by 20. Now, just remember, just like the previous question, you want to do division first. So what's 20 divided by 10? Well, 20 divided by 10 is 2. And then 2 times 3 is going to be 6. So I have a 6x there. All right, and then after that, I do 20 divided by 20. Well, 20 divided by 20 is 1. And then 1 times 7 is 7. So I have a plus 7y. And then finally, since I don't have any fractions on the constant term over here in orange here, you can just multiply here. So that's 20 times 1. 20 times 1 is going to be 20. Okay. So as you can see, I now have a new system here in blue. I have no more fractions. The fractions are gone. And I would just solve this using the elimination step now. And when you're using elimination, I have a 5 here and a 6 here. So I will go ahead and try to eliminate the x variable. So I have to make sure that the leading coefficients in front of the x variable are the same. Now, I have a 5 and a 6. So what's the least common multiple between 5 and 6? Well, if you're not sure, just multiply 5 and 6 together, and if you do that, you'd get 30, right? So the least common multiple between 5 and 6 is going to be 30. So ask yourself, what do you have to do to this 5 right here to get to a 30? Well, you would times everything by a 6, right? Okay, so what's 5 times 6? 5 times 6 is going to be 30, so 30x. And then 6 times 24, if you want to go to your calculator, you get 144, so 144y. And then 6 times 380 is going to be a big number. That's going to be, I believe, 2,280, and I did use my calculator to quickly do that. All right, so that's it for the first equation there in blue. Now, on the second equation here, which I'm trying to I'm putting in orange brackets here, you want to multiply this by 5, right? Because if you multiply this by 5, what's 5 times 6? 5 times 6 is the 30, right? So that would be 30x. And then 5 times 7, 5 times 7 is going to be 35, so plus 35, so plus 35y. And finally, 5 times 20 is going to be 100. All right, so there's quite a bit of steps that we have to do for this problem to get into a situation like this where we can now subtract both equations and solve for the y variable. So let me subtract this, right? So remember, we're doing 30x minus 30x, which is 0. So the x variables cancel. And then you have 144y minus 35y. So 144 minus 35 is going to be 109. So 109y equals. And then finally, you have 2,280 minus 100. And if I do that, I get 2,180. And then from there, I would just divide this by 109, divide that by 109. And feel free to use a calculator here. 2,180 divided by 109 is going to be 20. All right, so that's looking pretty good. We did all that work to find y. Now we need to go back and find x. Now, the best way to do that is, let's go back to maybe the second equations here. Let me just kind of erase all these distribution signs here. You can use any one of these equations here in the second step here to solve for the x variable. Let's go ahead and look at this box right here. If I recopy that below, I get 6x plus 7. Now remember, what does y equal to? Y equals to 20, right? We established that y was 20, so put that in a bracket and let's put a 20. And then this would equal to 20 on the right hand side. And let's go ahead and just figure this out. 7 times 20 is 140. And then this will be 20 on the right hand side. And then what we need to do next is you take this 140 and move that to the right hand side. So that's going to be 20 minus 140. Then I have 6x equals to negative 120. And then you can divide both sides by 6. And if you do that, x will equal to negative 20. So x equals to negative 20 and y would equal to positive 20 as your final answers. All right, so those are some very good review questions. And now let's get into what 6.4 is really about, word problems. And we'll do as many word problems as we can in this homework video guide. Okay, let's take a look at the first question here. The sum of two numbers is 6, and the difference is 10. Find the numbers. Okay, so whenever you're doing word problems, I recommend that you set up some let statements and establish what your variables are. So it says the sum of two numbers, right? So you're dealing with two numbers. So I would go ahead and start off with a let statement. So I can say let the first number be x. And then we can say that the second number be, let's let the second number be y. Okay, now that we know what x and y represent, let's go ahead and translate the sentences into equations here. So the sum of two numbers is 6. All right, so sum means add, right? So the sum of two numbers is 6. So sum means add. So you're taking x plus y. The sum of x and y is equal to 6. So there's your first equation. And then it says the difference. Difference means subtract. The difference is 10. Find the numbers. So the difference between x and y is 10. So the difference between x and y, that means x minus y would equal to 10. And there you go. Those are your two equations. If you want to label this as 1 and 2, you can. And we're going to use the elimination method here to solve for this. So in order to use the elimination method here, I noticed that there's a plus sign and a minus sign on the y's. So let's go ahead and just simply add these to eliminate the y variable. So if I have x plus x is going to be 2x. And then the y minus y, this y, and then you add that to a negative y, that just cancels out the y's. And then on the right hand side, I have a 6, right? 6 plus 10, right? So 6 plus 10 is going to be 16. All right, so I have 2x equals to 16. After that, you can divide both sides by 2. And then now we have x equals to 8. So the first number is going to be 8. And then let's go ahead and solve for the second number. If I just erase all this, I know the first number is going to be x. Sorry, the first number is 8. And if I go ahead and plug in 8 over here, now I have 8 plus y equals to 6, right? And then if I go ahead and solve for y by bring over the 8, I have 6 minus 8, which equals to negative 2. So my numbers are 8 and -2. And that's totally fine for full marks for my class. Okay, let's move on to the next question here. I have a perimeter of a rectangle type of problem. So the perimeter of a rectangle is 96. So if you want, you can go ahead and draw a rectangle out. And the length of the rectangle is 10 more centimeters than the width. Okay, so let's just label this. This is L, this is the width, and then this is the width. All right, so if you're dealing with a perimeter, we know the perimeter is 96, right? So I have two widths, so W plus W is 2W. And then we also have two lengths, right? So L plus L is 2L. So 2W plus 2L equals to 96. So there's your first equation, right? The perimeter is equal to 96. And then the length of the rectangle is 10 more than the width. Okay, so I have the length, right? The length of the rectangle is, so is means equals 10 more than the width. So the length is going to be the width plus 10 more. All right, so that's my second equation. L equals to W plus 10. Okay. Now, for this equation here, this system of linear equations here, you should notice that you have to use substitution here, and that's because the L variable here on your second equation, this is your first equation, this is your second equation, the L variable on the second equation, it's isolated already, right? So that means like half the work is done. So what I would do now is I would recopy out equation number 1, which is 2W plus, then you have this 2L, right? 2 times L. Now remember, what does L equal to? This L. L is equal to all of this, right? The length is equal to W plus 10. So if I put a bracket around here, instead of writing L, I'll write W plus 10. Because L is equal to W plus 10. And then you have 96 on the right-hand side there. That's great. And then let's use distribution here. The 2W can copy down. So 2 times W is 2W. And then 2 times 10 is 20, and that equals to 96 on the right-hand side. All right, now 2W plus 2W is 4W, and then plus 20 equals to 96. And then let's go ahead and solve this linear equation by moving the 20. The 20 would go on the right-hand side, so that would be negative 20 here. And then 4W would equal to, well, 96 minus 20 is going to be 76, and then you can divide both sides by 4. And after all that, 76 divided by 4, I'll just go with my calculator really quickly, that's going to be 19. So the width is 19. Okay, and then after that, I mean, you can just go back to, you know, probably the first equation here. Actually, the second equation is a little bit easier here. Let's take a look at your second equation here. I mean, you can use the first equation or the second equation, but it doesn't matter. We know that L is W plus 10, but we just found out that the width was 19, right? The width was 19, right? So in order to find the length is going to be 19 plus 10, which is going to be 29 centimeters. All right, so the length is 29 centimeters and the width is 19. And just to kind of check here, if you put like 29 centimeters here and then 29 centimeters there, and then if you put a 19 here and a 19 there, and if you just add up, if you add up all these blue numbers, 19, 29, 29, 19, you should get a perimeter of 96. Good. All right, so that's it for that question. Let's move on to question number 4 now. Two angles add up to 90 degrees. Okay, so whenever we have these two angle type problems or two number problems, I would start off with a let statement. I don't know, let the first angle. Actually, the language is using larger and smaller, so instead of saying let the first angle be x and y, let's just say let the larger angle be x, and then we can say let the smaller angle be y. Okay, so knowing that our larger angle is x and our smaller angle is y, I have two angles that add up to 90 degrees. So my first equation is not too bad. That's x plus y equals to 90. Now the larger angle, so the larger angle is going to be x, right? Is equal 12 more than 5 times the smaller numbers. So that's going to be 12 plus 5y. Okay, so for my second equation, here, I have x is equal to 12 more than 5 times the measure of the smaller angle. So there you go. There's my second equation there. X equals 12 plus y. Now from here, you should definitely recognize that since x is isolated on the second equation, x equals 12 plus 5y, you should use substitution right away. So here's my first equation, x plus y equals to 90, right? And you should recognize that this x, which is that x there, equals to all that, right? So this can replace all that. So x is equal to 12 plus 5y. So instead of writing x here, I can write 12 plus 5y, and then I can have a plus y here equals to 90. And then from here on, now you're solving the equation here. 5y plus y is going to be 6y equals to 90. And then this 12 here, I can move that to the right-hand side. Since 12 is positive, it becomes negative on the other side here. So this is 6y would equal to, now 90 minus 12 is going to be 78. All right, and then you can divide both sides of the equation by 6. If I do that, y, which is 78 divided by 6, that's going to be 13. Okay, so one angle is, so I guess the smaller angle is 13, and we know that, I think one of the first equation is x plus y is equal to 90, right? So since y is going to be 13, this is the same thing as x plus 13 equals to 90. Then you can subtract 90 from both sides. So 90 minus 13. If I do that, 90 minus 13 is going to be 77. So the bigger angle is 77 degrees and the smaller angle is 13 degrees. Okay, good work. Let's keep on going on here. A cafeteria has a special, 1 hamburger and 1 order of fries is $5.49. Okay, so I'll use H and F for fries. So H, 1 hamburger and 1 order of fries is going to be $5.49. So that's your first equation. I won't do let statements here because I think H for hamburger and F for fries is pretty simple. And then 1 hamburger, so 1 hamburger and 2 orders of fries, so that's going to be 2F equals to $6.99. All right, so from here, you would definitely use elimination here. And since we have an H here and an H here, you're better off by just subtracting right here, right? Subtracting. So H minus H is 0. Now, if I have an F minus 2F, F minus 2F is going to be negative F. And then if you have 549 minus 699, so 549 minus 699, that's going to be negative $1.50. And then you can divide both sides by negative 1, so F would equal to $1.50. So 1 order of fries is $1.50. Okay, great. So that's how we find the order of fries. Now we've got to find out how much does the hamburger cost. Well, let's go back to our first equation here. We always want to use the easiest equation. Okay, so I know that if I recopy the first equation, I know our order of fries is $1.50, right? All right, so just kind of recopy the first equation here. Erase that, and then you can just move the $1.50 over. So H would equal to 549 minus $1.50. And then you can get going here. So 549 minus $1.50 is going to be $3.99. So 1 hamburger is $3.99. And that's how you solve that particular question. Okay, let's see if we can do the last 2, 6 and 7, then we'll stop this homework video here. Ellie is twice as old as her sister Kate. Okay, so I won't write let statements because I think we'll use E for Ellie and K for Kate as her ages. So Ellie is twice. So Ellie is, so if I set my first equation, Ellie is, so that's E, and then is means equal, twice as old as her sister Kate. So she is twice as old as her sister Kate. So E and K represent their ages, right? So our first equation is E equals to 2K. Now our second equation, in 7 years, okay, so in 7 years the sum of their ages will be 20. Okay, so sum means we're adding. Okay, so 7 years from now, so right now Ellie is just E years old, And in 7 years, she's going to be 7 years older, right? Now for Kate, right now, she is just K years old. And then 7 years, she'll be 7 years older. And then if I add up their ages 7 years from now, they would add up to 20. Okay, so that's how you set this second equation there. And then I would collect like terms if you can. 7 plus 7 is going to be 14, right? So I have E plus K. And then 7 plus 7 is going to be 14. And then that's going to equal to 20 on the, sorry, not 140, 14. And that's going to equal to 20 on the right-hand side. And then if I keep on going here, I have E plus K. And then if you bring the 14 over to the right-hand side, 20 minus 14 is going to be 6. So there is my second equation there. So what I'm going to do with that second equation is I'm going to bring it over here, which is E equals to, sorry, not E, I have E plus K equals to 6. Okay, so there are my equations here, and I would go ahead and use substitution because we know that E equals to 2K, right? So when I see an E here, I'm going to replace that with 2K. So this is going to be 2 and K. So 2K plus K equals to 6. And then 2K plus K is going to be 3K. So 3K would equal to 6 there. And then divide both sides by 3. So cancel those guys off. And 6 divided by 3 is going to be 2. So Kate is going to be 2 years old. And if Kate is 2 years old, remember, if I just kind of highlight the first equation here in blue, we know that Ellie is 2 times Kate's age, right? So Ellie is 2 times Kate's age, and Kate's age is going to be 2, right? So 2 times 2 is going to be 4. So Ellie is 4 years old, and Kate is 2 years old. Okay, that's it for that question, and then let's go into question, the last question on this homework video guide, and then we'll do some of the harder questions on the next video. A car rental company charges X dollars to rent a truck and Y dollars per kilometer. Find X and Y if the rental charge is $90 for 100 kilometers and $110 for 150 kilometers. Okay. Okay, so I guess the question has already established that X is the cost to rent, and we know that Y is the cost per kilometer, right? So I guess the total cost, if I write out an equation for the total cost, it's going to be the rent plus the dollars per kilometer, and that's going to equal to your total cost. All right, so when you rent, you have to pay some money to rent the truck up front, and then you also have to pay money per kilometer. It's kind of like one of those cell phone questions where you have to pay money for the service charge plus money per text message that you sent, and that's going to be your total bill for the month. So similar idea there. Okay, now let's go ahead and take a look for the first one. The rental charge is $90 for 100 kilometers. So now it costs $90, right? So that's your total cost is 90 for 100 kilometers, right? So you drove 100 kilometers, so that affects the price per kilometer. Now you drive 100 kilometers and we're going to charge you per kilometer. I don't know how many kilometers you drove, but if you drove 5 kilometers, let's just say this is 5 kilometers, Y represents the price per kilometer as established in the problem there. If you drove 5 kilometers, you would times that by 100, and then it cost you $500 for your kilometers driven. And then since we don't know what the rent is, X will represent X. X is the amount that we pay to rent the truck. So X plus 100Y equals to 90. Once you do that, the second equation is a bit easier to set up. So it costs $110. And for you drive 150 kilometers, so that'll be 150 times Y. And then the cost to rent is going to be on the far left-hand side. Okay, so there you go. Your rent is going to be your X. Your dollar per kilometer is this, and finally your total cost is this here on the far right hand side. And there you go, you just solved this system equations here, and then you got it. This one's not too bad because the nice thing here is if you look at the x's here, the coefficients are the same, so you can eliminate this by subtracting. So x minus x is going to be 0, so those cancel off, and then you have 100 minus 150, right? So 100 minus 150 is going to be negative 50, right? So if you have $100 and you owe your mom $150, you still owe her $50. And then if you have 90 minus 110, that's going to be negative 20. And this is looking good. You can divide both sides by negative 50. And then y would equal to 20 over 50. Now 20 over 50 on your calculator is just 40 cents, right? So it's 40 cents per kilometer. So y is the price per kilometer, so it costs 40 cents per kilometer. Now if I rewrite the first equation was this: x plus 100y equals to 90. We know that y is going to be 40, right? 40 cents. So if I rewrite this, it'll be x plus 100 times 40 cents equals to 90. And then we just solve for y. Let me erase that. So I have x here plus, now 100, if you have 100 times 40 cents, that's going to be 40. And that would be 90 on the right hand side. So 90 minus, if I bring that positive 40 over, that becomes 50. All right, so it costs $50 to rent the truck, and it also costs 40 cents per kilometer for every kilometer that you drive to establish your total cost there. Okay, so that's it for this homework video guide, and we'll do another homework video guide for the next word problems.